Welcome back to A320 Knowledge, your trusted source for Airbus expertise. Today, we'll be diving into the Airbus Cost Index. An often misunderstood concept, even among seasoned Airbus pilots, the cost index plays a primary role in speed and altitude computations throughout the flight. The cost index is used to take into account the relationship between fuel and time-related costs in order to minimize the overall trip cost. Each individual airline calculates their own cost index for their specific aircraft variant and the sector being flown. The purpose of the cost index concept is to reduce the direct operating costs of the operation. Fuel is not the only concern when it comes to costs. Fixed time maintenance costs also play a role in determining the ultimate overall lowest cost of the operation, and therefore the optimum cost index. The cost index is defined as the ratio between the cost of time and the cost of fuel. It is normally expressed in either kilograms per minute or hundreds of pounds per hour. The minimum cost index value is 0. This is used when fuel conservation is the biggest priority. It provides the speed for the maximum range. The speed at cost index 0 is typically referred to as maximum range speed, MRC, and normally corresponds to green dot speed. The maximum cost index value is 999. This is used when time is the limiting factor. Crews normally input the chosen cost index into the init page of the MCDU during the preliminary cockpit preparation stage. The cost index is a strategic parameter that applies to the whole flight, and it can be modified by the crew during the climb, cruise, and descent phases on the perf page of the MCDU. The cost index affects the managed speed target and the optimum cruise altitude located on the Progress MCDU page. The managed speed target is calculated using the cost index and is referred to as the econ Mach number. For a given cost index, the econ Mach number is defined as the Mach number for which the direct operating costs are at a minimum. Econ Mach is also affected by the aircraft gross weight, wind, temperature, flight level, and performance factor. When using a cost index, the econ Mach will increase in a steady headwind. This gives the aircraft less exposure to the increased winds. Conversely, the econ Mach will decrease in a steady tailwind. By letting the tailwind work for the aircraft, this balances the sector flight time against the fuel usage. An airline typically chooses a cost index in between the maximum range cruise speed and the long-range cruise speed. The long-range cruise speed is a traditional cruise speed that is equivalent to the Mach number equal to 99% of the maximum specific range. Simply put, LRC gives a 3 to 5% increase in speed above the MRC speed, whilst only suffering a 1% decrease in fuel penalty. As an example, the cost index for long-range cruise using CFM LEAP 1A engines is 40. Let's take a look at Airbus's guidance to further consolidate our understanding of the cost index.
Hi there. Cost index is one of those subjects which is not always well understood by pilots. In this Airbus Wind video, I want to provide you instructors with some material to allow you to brief your trainees on what cost index is, what it's not, and also offer some guidance on its use in the cockpit. The background is that we're living in a commercial world. Airlines need to make a profit, and profit is revenue minus costs. In the cockpit, pilots have no control over the revenue generated on a flight, but they do have a degree of control over the costs incurred during a flight. Now let's look at these costs. Some are fixed costs or overheads. Pilots have no control over these. Some of the costs are linked to the duration of the flight. For example, airlines might pay for some components per flight hour. Another example would be flight crew pay. And the other cost is the cost of fuel burnt. If we look at these last two costs, pilots can influence these by their choice of cruise speed. If pilots fly fast, time costs will be reduced, but more fuel will be burnt. If they fly slower, they will nearly always save fuel, but the time cost of the flight will increase. So, what is the best solution? Well, there's no single answer to this. If you operate in a region where fuel is very expensive, you're probably best off flying slowly. If your crew pay has a high element of flight time pay, or your company has some major power by the hour contracts, flying faster might be an option. The issue is, what is more costly? A few kilograms more fuel or a few minutes extra flying time? Now this is what Cost Index does. Cost Index is an exchange rate between the cost of time and the cost of fuel. So a high cost index means that for your airline, flight time is very important. A low cost index means that fuel costs dominate. And as an example, a cost index of 80 means that 1 minute more flying time costs the same as 80 kilograms of fuel. You enter the cost index into the FMS. The FMS then combines this with its onboard performance database and produces a managed speed. Sure, if you vary the cost index, speed will change. But remember, that is not the purpose of cost index. It's worthwhile considering that to calculate a cost index, you need access to your airline's accountancy department. You need to know pay rates, lease rates, and fuel costs. In the cockpit, you've no way of knowing all this data, so don't go changing it. These figures will vary from one airline to another. So if you're flying and you look at your nav display, you see a competitor's aircraft, same type, route and altitude as you, but going faster or slower, it could well be that he is flying to a different cost index to you, just due to the differences in your airline's costs. So, remember, our objective is to minimize mission costs, not just fuel burn. Cost index is an exchange rate between the cost of time and the cost of fuel. Cost index is what is used to ensure the best speed, the speed for lowest costs. Okay, so we now know what cost index really is, but how do you use it? Both your flight planning system on the ground and your FMS in the air have a mathematical model of the aircraft and convert cost index into a desired cruise mark number. So, before your flight, the flight plan is computed at optimum cruise mark number. And when you receive your flight plan, the times, fuel on board at each waypoint, and step climbs are all calculated. In flight, the crew should use the same cost index. If you fly at a different cost index, and hence different speeds, your actual flight will differ from the flight plan. The flight times, fuel on board, and RecMax flight levels will deviate from predictions, and this leads to two problems. Firstly, a more expensive flight, and also a loss of crew confidence in predictions. This results over a period of time in crews uploading more contingency fuel, creating greater and greater fuel burns. Remember, the cost index is derived by people on the ground with access to your airline's finance details. In the cockpit, you simply do not have access to all of this data. The guidance is simple. Fly at the cost index used on your flight plan. With the information available to you in the cockpit, you simply cannot do any better. Before I finish, I would just like to touch upon a more complex issue. Are there any scenarios where changing the cruise speed is an option? The most common question relates to winds aloft. What happens if the en route winds have changed since your flight plan was produced? Well, firstly, remember, cost index is simply a ratio between time costs and fuel price. Wind does not come into the equation, so does not change cost index. So the answer is, if the winds you encounter differ from those on the flight plan, fly at cost index and simply, if needed, deviate from the flight plan flight levels to fly as close as possible to opt flight level. And check your FOB at destination. Let's look at two further examples. Firstly, imagine that you're going to arrive at destination too early and that you know you're going to have to go into the hold. Here you have two choices. Either you maintain your current speed, then burn extra fuel in the hold, or you slow down. In flying slower, you will usually burn less fuel and there will be no holding. This is almost certainly a good option and a choice that you can make from the cockpit. Our two pieces of guidance would be: modify your speed using the FMS's RTA function and check the FOB at dest prediction in the FMS. The opposite scenario is not so clear-cut. Imagine you're running late and that some of your passengers will miss onward connections. This could be costly for the airline in terms of compensation or hotel accommodation. So maybe you or your ops control center will consider speeding up. Well, firstly, you will save money in terms of airline time costs. Also, any compensation needs to be considered. But as a pilot, you are not aware of these. However, in the cockpit, you are fully aware of your fuel situation. By using the RTA function, you can assess how much more fuel you will burn. The OCC might need to know the extra fuel burn when making their assessment. But the key point is you will burn more fuel, so check FOB at destination. Okay then, to summarize, remember, cost index is purely an exchange rate equating the cost of time to the cost of fuel. It is not a speed control mechanism. By sticking to your flight plan cost index, you will fly at minimum cost, not the same as minimum fuel burn. So, in the cockpit, do not improvise. Lastly, if there is an additional issue like a time constraint, you can consider changing your cruise speed, but remember, to make this decision, you might need help from your OCC. Use the RTA function, but always check fuel on board at destination. If you change plan, have you got enough fuel on board?
Thanks for tuning into this tutorial on the cost index.